Welcome to this explainer, where we're going to completely decode the AP Computer Science Principles Big Idea 5 study guide into a clear, actionable roadmap. Look, if you're gearing up for this exam, or honestly, if you just want to figure out how the digital world is fundamentally rewiring our society, economy, and culture, you're in the exact right place. We're going to break down these massive computing concepts so you can master this material fast. Let's get into it.
Okay, so here is our agenda. We are taking this giant concept of computing impacts and breaking it down into 6 highly focused, highly testable sections: the innovation impact, the digital divide, computing bias, laws and ethics, safe computing, and finally a super simple memory framework to tie the whole shebang together.
But before we even look at the facts, I want you to ask yourself a question. Does a new app or algorithm primarily solve our problems? Or does it kind of just quietly invent new ones we haven't even noticed yet? Well, the reality is it's always both. Computing innovations solve incredible problems, but they always create new ones. And that is the exact mindset you need to hold on to as we analyze the impacts of modern technology today.
Let's kick things off with Section 1, the innovation impact. We call this the double-edged sword.
Because let's be real, there's absolutely no such thing as a technology with zero side effects. An innovation like GPS or AI can be incredibly good or surprisingly bad, depending entirely on the user, the context, and how widely it's adopted. Think about GPS. The intended benefit? You literally never get lost. But the unintended harm? Your location and privacy are constantly being tracked. Or take social media. It connects us seamlessly, but scaled up to billions of users, the unintended consequence is a massive spike in mental health issues. A single tech feature can be a lifesaver and a hazard at the exact same time.
Moving right along to Section 2, the digital divide, where unequal access leads directly to unequal opportunity.
Now, a lot of people think the digital divide is just about whether or not you own a laptop. Actually, scratch that. It's way deeper. It's broken down into 3 distinct gaps. First is the access divide. Maybe you're in a rural town without broadband. Then there's the knowledge divide. You have a smartphone, but maybe you have no idea how to navigate a digital job application. Finally, the usage divide. You know the basics, but lack the advanced technical skills needed to truly compete. Simply handing someone a tablet does not automatically close this gap.
So here is a massive AP tip for you. Whenever you write about or analyze the digital divide, always explicitly connect it to real-world equity. This isn't just a quirky technical glitch. This divide directly creates devastating education gaps. It deepens job inequality, and it severely reduces a person's ability to just participate normally in modern society.
All right, Section 3, computing bias. Let's see what happens when human flaws get hard-coded right into our machines.
We need to bust a common myth right now. Computers are not perfectly objective judges. They can and do produce highly biased outcomes based entirely on how they were built. Machines are built by flawed people, and they are trained on data generated by flawed people. So naturally, they inherit all of our blind spots.
So how does this bias actually sneak in? Usually through 3 main doors. First up is the data itself. If you feed an AI a limited or completely skewed dataset, it's going to fail miserably when it encounters the real, diverse world. Second is flawed design right there in the algorithm. And third, a sheer lack of diversity in the engineering room where the tech is actually being built.
And we're not just talking about abstract ideas here. The real-world impacts are brutal. Imagine an automated loan system unjustifiably rejecting a qualified family, or a hiring AI secretly filtering out specific demographics, or facial recognition failing entirely for minorities. To stop this, we absolutely must use diverse datasets, rigorously test our algorithms, and make sure we have completely diverse teams sitting at the table.
Which leads us perfectly into Section 4, laws and ethics, the rules of the digital road. Technology moves at lightning speed, but it still has to follow some standards. Knowing your intellectual property is an absolute lifesaver. You have got to know the difference between Creative Commons, open source, and open access. If you see a Creative Commons license, it means you can share that work as long as you get permission or give credit. Open source, like Linux for example, means anyone is free to jump in and modify the code. And open access? That just means it's totally free for anyone to look at. Stealing this stuff without credit is plagiarism, pure and simple.
But it's really important to separate hard legal issues from messy ethical ones. Strict laws govern things like copyright, intellectual property, and piracy, but ethical issues, those are the moral gray areas. Take crowdsourcing. It's amazing because you can use huge groups of people on the internet to solve problems at record speed,
But the trade-off is a massive lack of quality control, like seeing a totally made-up fact on Wikipedia. We are constantly navigating this tension between what is strictly illegal and what is just a really bad ethical idea.
All right, Section 5, Safe Computing. Time to shift gears, play some defense, and talk about protecting your data in a pretty hostile digital landscape. Let's talk about your PII, your personally identifiable information. This is the holy grail for data brokers. It's the stuff that uniquely identifies you. Your social security number, your phone number, your search history, your exact location. This data is constantly being scraped up by cookies and trackers. Once it's out there, it opens you up to identity theft and corporate surveillance. And trust me, it is incredibly difficult to ever get back.
To keep that data locked down, we rely on encryption. You need to know the difference between two main methods here. Symmetric encryption is like a single house key. You use the exact same key to lock and unlock the data. But public key encryption uses a mathematical pair. You use a public key to lock the data up, but only the corresponding private key can actually unlock it. This dual key method is literally what makes secure browsing on the internet possible today.
But honestly, attackers often don't even bother trying to break through that complex encryption. Why hack a firewall when you can just trick a human? That's phishing. It's one of the most common threats you're going to face. You get a totally fake email that looks exactly like it's from your bank, designed to panic you into typing in your password. It is cheap, it is easy, and unfortunately, it works.
Add phishing to a whole landscape of other threats. You've got malware acting like a virus to wreck your system, you've got keyloggers silently recording every single keystroke to steal your passwords, and you've got rogue Wi-Fi, those fake networks labeled free airport Wi-Fi that just intercept everything you do. Your best defense against all of this? Multi-factor authentication. By requiring your password, plus a specialized text code, you make it almost impossible for an attacker to get in, even if they stole your password.
Okay, home stretch. Section 6, the IBDCLS framework. I'm going to give you the ultimate mental framework to tie everything we literally just talked about completely together.
Whenever you are analyzing any new tech, I want you to run it through this exact process. Trace the innovation to its impact, see exactly how it uses data, evaluate the ethics, and identify the risk. So if someone hands you an AI chatbot, don't just say it writes essays. Talk about its beneficial and harmful impacts. Talk about the insane amounts of data it collects, the bias hidden in its training, and the security risks if its servers get breached.
And to make sure you literally never forget this on test day, just memorize the acronym IBDCLS: Impact, Bias, Digital Divide, Crowdsourcing, Legal and Ethics, and Security. If you can instantly recall those 6 pillars, you can expertly evaluate absolutely any computing innovation the world throws at you.
As we wrap up this explainer, I want to leave you with this thought. If every single click, search, and message you send becomes data, what unintended consequences will your digital footprint create tomorrow? Your personal data is literally fueling the next generation of innovations. So what kind of future are you helping to code? Computing is this unbelievable tool that amplifies our greatest problem-solving abilities, but also our deepest human flaws. Getting a grip on these impacts is the first big step to making sure the tech of tomorrow actually serves all of us. Keep learning, stay curious, and I'll catch you next time.